Today we are going to talk about finding maximum and minimum of a quadratic function. Just to recall that the quadratic function can be written in three forms. The first one is called standard form, where f of x is given as ax squared plus bx plus c, where a, b, c are all real numbers, and a cannot be equal to 0. If a is 0, then it becomes a linear equation. Now the advantage of standard form, as we said before, is the y-intercept, which is the constant c. And remember, to find the y-intercept, we set x equal to 0. If you set x equal to 0, these two terms are going to be equal to 0, so you're going to end up with c, which is the y-intercept. The next form of a quadratic equation is the vertex form, which is written as f of x is equal to a times x minus h squared plus k, where a, h, and k are real numbers and a cannot be 0. Since if a is 0, then it becomes f of x is equal to k, which is a line. Now the advantage of having the quadratic expressed in vertex form is the coordinate of the vertex. The coordinate of the vertex is h and k, where x coordinate of the vertex is h and y coordinate of the vertex is k. The only thing you have to remember is that the vertex form is in the form of x minus h. Remember that. Now, if a is greater than 0, the quadratic opens upward, so the vertex is a minimum, opens upward, so the vertex is minimum, and if a is negative, quadratic is going to open downward, so the vertex, which is this point, is going to be a maximum. The last form of a quadratic equation is what we call factored form or x-intercept form, which is again f of x is equal to a times x minus r times x minus s, where r and s and a are real numbers and a cannot be equal to 0, because then f of x is equal to 0, which is going to be a point. It's going to be a line, which is not a quadratic anymore. Now, r and s are the x-intercepts or the zeros of quadratic. Now, if you have a quadratic in standard form and you would like to change it to vertex form, as we did before, we are going to use the completing square method. Or, as we said in the class, there is another easy way to find the x-coordinate of the vertex, which is minus b over 2a, and then sub it back inside the equation to get the value of the y-coordinate of the vertex, and then we can express, the standard form in vertex form using the a value from quadratic. So let's do a couple of examples here. The first example is a function f of x is negative 2 over 3x squared plus 8x plus 5. We are supposed to find the coordinate of the vertex and also the vertex form and decide is the vertex maximum or minimum. Just by looking at this equation, you can see that the a value is negative 2 over 3, and since a is negative, then we know that parabola or the quadratic opens downward, so the vertex has to be a maximum. That's a given fact. Now let's see how we can change this one to a vertex form by completing squares. The first thing, as we said before, we are going to use brackets over the x term. So we're going to have negative 2 over 3x squared plus 8x, close bracket, plus 5. Now I'm going to take negative 2 over 3 out because the coefficient, the leading coefficient has to be 1. So it's going to be negative 2 over 3 x squared. Now 8 divided by negative 2 over 3 is the same as 8 times. So we can say 8 divided by negative 2 over 3, because we're factoring, is the same as 8 times negative 3 over 2. 8 divided by 2 is 4, so it's negative 12. So we get negative 12x plus 5. Now we have to divide negative 12 by 2, which is negative 6, and then square it, which is 36, add and subtract from the bracket. So we are going to have negative 2 over 3 times x squared minus 12x plus 36, and then subtract 36 plus 5. And since you are adding and subtracting 36, nothing is changed. Now, if you remember, we are going to package the first three terms together. And since this one is minus, negative, and the square root of 36 is 6, square root of x squared is x, we are going to write this one as negative 2 over 3, and it's a perfect square, x minus 6 squared minus 36 plus 5. Again, just to check, x minus 6 squared is x squared plus 36 minus 12x, which is what we had before. Now I'm going to distribute negative 2 over 3 inside the bracket. I get negative 2 over 3 x minus 6 squared. Minus times minus is positive, so I get plus 2 over 3 times 36 plus 5, which is negative 2 over 3 x minus 6 squared. Now 36 divided by 3 is going to give you 12. 12 times 2 is going to give you 24. So 24 plus 5 is going to give you 29. So this means the vertex is 6 and 29. And since the leading coefficient is negative 2 over 3, which is negative, then we know the parabola opens downward, and the value is the vertex maximum, and it's equal to 29. The next question asks to find the vertex of the function y equal 4x squared minus 12x plus 3 by partial factoring, which I'm going to explain to you what exactly it means. And the question is that, is the vertex a minimum or maximum? The second part of the question is simple to answer because leading coefficient is 4 is positive, so the parabola opens upward, so the vertex is a minimum. Now, what exactly is partial factoring? Partial factoring states that when you have a quadratic in standard form like this, y equal 4x squared minus 12x plus 3, this represents a parabola looks like this one, let's say. Now, if you remember from grade 10, this plus 3 represents a translation vertically upward by 3 units. So if the base function for this guy is somewhere around here, this means that this guy has been translated 3 units upward. This means that the x-coordinate of the new parabola, which is this one, so this is the new parabola, which is this guy, compared to the parabola which is represented by y equal 4x squared minus 12x, which is this guy, they have the same x-intercept, x-coordinate for the vertex. The only difference is that the second parabola, which is this guy, has been translated 3 units upward. So if we can find the x-coordinate of the parabola, which is 4x squared minus 12x, the x-coordinate is going to be the same for the original parabola. So how do you find the x-coordinate of vertex here? To do that, I'm going to find the x-intercepts, and then I'm going to find the average of these. So I'm going to make this one equal to 0. Remember, to find the x-intercept, we set y equal to 0. So to solve this one, I'm going to either use quadratic formula or I'm going to use factoring. Probably factoring is easiest, so I can take 4x out. 4x squared divided by 4x is x, minus 12x divided by 4x is 3, is equal to 0. I either get 4x is equal to 0, which means that x is equal to 0 is 1x intercept, or x minus 3 is equal to 0, so x is equal to 3. Remember, when two numbers are, the product is 0, either one of them or both of them, they have to be 0. So we know that the x-intercepts are 0 and 3. So we say that v sub x is 3 plus 0 divided by 2, which is 3 over 2. So the vertex, the x-coordinate of the vertex is 3 over 2. Now what I'm going to do, I'm going to put it back in the original equation, and I'm going to find the y-coordinate. So it's going to be 4 times 3 over 2 squared. Remember, I'm using brackets because I'm doing substitution. Minus 12 times 3 over 2 plus 3. Now 3 over 2 squared is 9 over 4. 12 times 3 over 2 plus 3. Now 4 cancels with 4, so I get 9. 12 divided by 2 is 6. 6 times 3 is 18, so minus 18 plus 3. And here I'm going to get 12 minus 18 is going to give me minus 6. So the y-coordinate is negative 6, so we get vertex is at 3 over 2 and negative 6. And again, since the leading coefficient is 4 positive, parabola opens upward, so it's a minimum, and the value of the minimum is negative 6. This is the value of the minimum. The next example, we have Rachel and Ken, which are selling scarves. We know that every scarf costs $6, and they plan to sell it for $10, and this $10 was last year, and they could sell 40 scarves. But this year, they found out that they can increase the price by 50 cents, and every time they increase the price by 50 cents, then there is going to be 4 less scarves that they can use, they can sell. The question is at what selling price will maximize their profit, and what will the profit be? So we are going to start with a let statement. So we are going to say let n to be number of times price is increased by $0.5 or 50 cents. So the total profit, which we call it with P as a function, is equal to, remember that every scarf, the profit is $4 because the cost is $6, they sell it for $10, so it's $4, but let's assume that n times the price is increased, so it's 4 plus 0.5n. Now, this is the profit per scarf. And remember that they used to sell 40 scarves without increasing the price. But every time they increase the price, they sell 4 less scarves. So the number of scarves sold is 40 minus 4n. So this means the following, that if they don't increase the price at all, so n is 0, this means that the profit is 4 times 40, because point n and minus 4n is become 0. But if they increase by 1 time, 50 cents, then the profit is going to be 4 plus 0.5 times 1, which is 4.5, which is $4.50, times 40 minus 4, which is 36, which is correct. So this is the equation that we have to maximize. So let us expand this function. We are going to have 4 times, okay, I'm going to use arrows. 4 times 40 is 160. 4 times negative 4n is going to give me negative 16n. 0.4 times 0.5n times 4n is going to give me 0.5n times 40 is going to give me plus 20n, and 0.5n times negative 4n is going to give me negative 2n squared, which is going to be negative 2n squared. 20n minus 16n is going to give me 4n plus 160. Now looking at this one, you can see that this is a parabola, and since leading coefficient is negative, parabola opens downward. So this means that the parabola looks like this one, and the vertex is going to be a maximum point, exactly what the problem wants. Now to find the coordinate of the vertex, you can either use a quadratic formula, find the x-intercepts, find the average, and then evaluate the y-coordinate. That's one solution. That's the other solution, completing squares. That's possible too. Or the easiest one is the shortcut. Remember the formula, v sub x is minus b over 2a, so it's minus 4 over 2a, 2 times negative 2, which is negative 4 over negative 4, which is 1. This means, this is not v sub x, this is v sub n, because the variable n is really x. So this means that if you increase the price only once, the maximum profit is obtained. So this means that the new price, so the price for maximizing is going to be 10 plus 1 times 0.5, which is going to be $10.50. So if they increase the price only once, then they are going to maximize their profit, which is going to be for $10.50 scarf. Now, if you want to know what is the maximum profit, what we are going to do is that we are going to sub the value of v sub n in the equation to find p. So p becomes 4 plus 0.5 times 1 times 40 minus 4 times 1, which is going to be 0.5, so it's going to be 4.5 times 40 minus 4 is 36, which is equal to 162, which is the maximum profit. In the next example, we have Jamie, which throws a ball that will move through the air in a parabolic path due to gravity. The height is given by this formula here. We are supposed to find the zeros. To find the zeros, we just make h equal to 0, use quadratic formula, and solve the problem. So we are going to say negative 4.9 t squared plus 40t plus 1.5 is equal to 0. So from here, we say that t is minus b minus 40 plus or minus the b squared. 40 squared is 1600 minus 4ac, so it's minus 4 times negative 4.9 times 1.5 divided by 2a, which is 2 times negative 4.9. If you simplify the under the square root, and then take the square root, and also simplify 2 times negative 4.9, you get negative 40 plus or minus 40.4 divided by negative 9.8. This one gives you two solutions. Either you go with positive. If you go with positive, you get negative 0.04. If you go with positive, negative, you get 82 seconds. Now, to interpret the meaning, you have heard before that time can't be negative. But this negative means, if you look at the context of the problem, this is the way that the ball is thrown and it hits down here. From here to here, it takes 8.2 seconds. Now, if we continue the parabola to the left of the y-axis, which is negative 0.04 seconds, this means that if 4 seconds in the past, okay, if the ball was thrown in the air, it will follow this path to hit down here. So this is the negative 0.4 means in the context of the problem. The next part of the problem says, how long does it take for the ball to reach the maximum? We have to find the t-coordinate of the vertex. We know the zeros are given, so we just add and divided by 2. So we say that the time, or v sub t, the time that it reaches the maximum is 8.2 plus negative 0.04 divided by 2, which is going to be 4.08 seconds. So this means after 4.08 seconds, the ball reaches its maximum. And the last part says, what is the maximum height of the ball? So what we do, we just substitute back the value of 4.08 in the equation to find v sub y, or v sub h. So we say v sub h is equal to negative 4.9 times 4.08 squared plus 40 times 4.08 plus 1.5. If you simplify this one, you get 83.13 meters. So this means that the maximum height that the ball reaches is 83.13. So the vertex is 4.08 and 83.13.